12 meters, water table is at 6 meters, hence it is divided into 6 and 6. Suppose in some conditions what they will give, they will give the height of the wall as 3 meters, height of the wall as 10 meters, and water table is available at a depth of 2 meters from the horizontal ground surface. In those situations, H1 it will be 2 meters, H2 it will be 8 meters. You should have to see those values. Next we are having half into gamma W into half into Ka into gamma W into H square. H square we are having 36. Plus next we are having half into gamma W into H square. That half into gamma W as 9.81 into H2 square. Again we are having 36. The total horizontal earth pressure PA equal to, if you calculate the value you may get. If you see here, in some conditions the unit weight of water we are taking as 9.81. In some person they will take the unit weight of the water as a 10 kg per meter cube. That is not wrong. You will make it values little bit nearest to the values. Okay. Now we will calculate this all total pressure diagram. Okay. First I will write the PA1, PA2, PA3 plus PA4. PA1 value I will write here 0.50 into 0.4059 into 17.7 into 36. Okay, I am getting this PA1 value as 129.31 kilonewton per meter. Next we are having this area of this pressure diagram. That area of the pressure 0.4059 into 17.7 into 36. Okay, I am getting this area of the pressure diagram PA2 as 258.63. Again, if you see here PA3 value, the PA3 value 0.50 into 0.4059 into 10 into 36. Okay, PA3 value I am having 73.06. Next we are having the area of the last pressure diagram, that is area of the pressure diagram due to the core water pressure, that is 0.5 into 9.81 into 36. Okay, 176.58 kilonewton per meter. If you observe here, the core water pressure also will creating more pressure on the wall. Now I am finding the total active earth pressure acting on the wall due to the layer 1 and layer 2 as well as core water pressure. 129.31 plus 258.63 plus 73.06 plus 176.58. Okay, total I am getting it as 637.58 kilonewton per meter. 637.58 kilonewton per meter. Again I am repeating one more time here. If you are writing here total active earth pressure acting on the wall, then you should have to mention here 637.58 kilonewton per meter. Otherwise, if you are writing as total active thrust per meter length of the wall, in that situation you should have to write it as 637.58 kilonewton. If you are mentioning here per meter length of the wall, here you should have to end with kilonewton. If you are mentioning here only active earth pressure, then you should have to use the 637.58 kilonewton per meter. Next, we have to calculate the magnitude of point of application of the load. Suppose here, if you see here, for this pressure diagram, here due to this presence of soil, the earth pressure it will be acting 129.31 kN per meter square. Here the pressure it will may act 129.31 kN per meter square. Here it will may act 258.63. Here 73. Here 176. For all these pressure diagram, the resultant pressure at how much distance it is acting, that we have to calculate. That is nothing but magnitude of point of application of the load. Okay, I am writing here the magnitude of the magnitude of point of application of the load, the magnitude of point of application of the load, the magnitude of point of application of the load, the magnitude of point of application of the load, that is nothing but Z. The magnitude of point of application of the load is nothing but PA1 into. Okay, before writing here, I will explore the diagram. If you see here, for this the earth pressure will be acting triangular portion H by 3. For this rectangular, H by 2. Again for this triangular, H by 3. Again for this triangular, H by 3. Okay, that is the magnitude of point of application of the load. That is nothing but PA1 into H by 3 plus next we are having PA2 into PA2, we are having the rectangular portion, hence PA2 into H by 2. Next nothing but H1 by 2. Here also H1 by 2. Okay. Next we are having the one more pressure diagram, that is nothing but PA3 into H2 divided by 3. Okay. Next we are having PA4 into H2 divided by 3. Total divided by total active earth pressure. Total active earth pressure is nothing but PA1 plus PA2 plus PA3 plus PA4. This is the total active earth pressure. From this we are calculating the magnitude of point of application of the load. Already PA1 value we have calculated. That calculated value it will be 129.31. PA1 equal to 129.31 into H1 by 3, where H1 is the height of the wall, 6 by 3. Okay. Next we are having the PA2 how much we are having? 258.63. 258.63. Next we are having rectangular portion we are having H1 by 2. H1 by 2 means 6 by 2. Okay. Next we are having PA3 I think 73.06. okay. PA3 we are having 73.06 into H2 by 3. H2 by 3 means again 6 divided by 3 plus PA4 we are having 176.58. 176.58 into H2 by 3. H2 6 divided by 3. Total divided by we are having PA1 plus PA2 plus PA3 plus PA4. That means this value plus this value plus this value plus this value. That calculated value already PA1 PA2 we have calculated, that it will be 6. Okay, and that we are here 637.58. If you see here the total PA value we are having PA equal to 637.58 kilonewton per meter. Okay. Next I am writing this total value, but it will be 637.58. 637.5. If you calculate this, you will get the point of application of the load. Okay, I am calculating the point of application of the load. That is nothing but 3 1 2 3 2s. 2 ones into 2 3s. 3 1 into 3 3s. And 3 1 into 3 2s. Okay, simply you can double. 129.31 into 2 plus 258.63 into 3 plus 73.06 into 2 plus 176.58 into 2. Okay, divided by we are having 637.58. Okay, 2.40 meters. Okay, we are having the point of application of the load we are having at a height of 2.40 meters. This is the point of magnitude of application of the load. Point of magnitude of application of the point of magnitude of application of load or force for meter length of the wall. That means if you see here your retaining wall, for this retaining wall the total horizontal pressure it will may act at a height of 2.40 meters. Up to now this is the problem how we are calculating for the lateral earth pressure when retaining wall is given having two type of soil layers. Already I explained this problem. The same problem how they can ask in our examination also I may repeat by showing the one more diagram. Suppose if you see here, this is your retaining wall. For this retaining wall, this is the one layer of the soil. They will give here phi equal to 25 degrees and unit weight of the soil mass as gamma d1, and again here they will give the angle of intersection as pi equal to 30 degrees and they will give the unit weight of the soil mass as gamma d2. They will ask for this to calculate the lateral earth pressure. If suppose here this is the saturated unit weight, there is one more pressure diagram it will may come. If it is only the dry unit weight, only two pressure diagrams will come. Okay, for this I will show the pressure diagram. Suppose this is your retaining wall. For the retaining wall, if you see here, due to soil here, one pressure diagram will be come here. The same pressure diagram will be distributed to this portion. Suppose if you see here we are having the one more soil layer. For this soil layer we are having the pressure diagram. It will be like this. Here we are having the earth pressure at base of the wall as Ka1 into gamma 1 into H1. Here this is the H1 of the soil mass and this is the H2 of the soil mass. This is phi 1 and this is phi 2. This is gamma d1 and this is gamma d2. Again the same pressure also will be available here. That is nothing but Ka into gamma 1 into H1. Here it will be Ka2 into, where because of this changing of angle of intersection, the coefficient of earth pressure it will may change. That is nothing but Ka2 into gamma d2 into H2, where here H1 and H2 are different. It will, for this type of problems, the pressure diagram it will be like this. Suppose for the same problem, if they are asking in the question, there is a water table at this present, water table is available at this level. In those conditions, instead of gamma d, we will take it as gamma submerged. When the soil mass is in submerged condition, the previous problem what we have solved, like that we have to solve. Okay, otherwise I will show here. Okay, suppose this is your retaining wall. For this first the pressure diagram, the pressure diagram due to presence of this line it will be happen like this, and the same pressure will be distributed up to this particular height. And again here we are having the one more soil. Due to this soil, again the pressure diagram will be created here. It will be like this, and here we are having the pore water pressure, that is in a submerged condition. Due to submerged condition, one more layer it will be acting. Here nothing but we are having Ka1 into gamma 1 into H1. The same pressure will be repeating here, Ka1 into gamma 1 into H1. If you see here, Ka2 into gamma sub into H2. Ka2 into gamma sub into H2. Here nothing but gamma W into H2. How these are the different types of problems they are going to ask in your examination. Solve by yourself for such type of problem. Majorly they will ask the problems by considering the two layers of the soil mass. What is the problem we are discussing in this present condition? Up to now, this is the problem for the lateral earth pressure. Next we will see the one more problem. Okay, next we will see the one more problem. Okay, the problem is problem number 6. Okay, next problem is problem number 6. The problem number 6, if you see here, the problem is a wall 5.4 meter height retains sand in loose state. Sand has wire ratio of 0.63 and the angle of intersection pi equal to 27 degrees. While in the dense state, the corresponding values of wire ratio 5 and angle of interflexion as 0.36 and 45 degrees respectively. Compare the ratio of active and passive earth pressure in the two cases, assuming G equal to specific gravity of the soil, G equal to 2.61. Here they given one retaining wall, height of the retaining wall. They consider in first case as a loose state, and they are considered in second stage as a dense state. We have to calculate the ratio of active earth pressure when the soil is in dense state to the comparison of when the soil is in a dense state. The ratio of active and passive earth pressure, both that we have to calculate. Okay. First, before calculating this, first we will draw the diagram. Okay. If you see here, suppose this is your retaining wall, and this is your retaining wall, and this is the height of the, and this is the height of the wall. The height of the wall h equal to, we are having 5.4 meters. Height of the, we are having as h equal to 5.40 meters. Height of the wall we are having h equal to 5.40 meters, and they are given the soil parameter. Suppose this is your backfill. I am assuming this as backfill. Suppose if the soil is in a backfill as loose state, for a loose state they are given the wire ratio of the soil E equal to 0.60 and angle of interflexion as pi equal to 27 degrees. Okay, suppose here this is the height of the retaining wall, h equal to 5.40 meters, and here the soil having these parameters. For these parameters, first we have to calculate the active earth pressure, passive earth pressure. Next they are asking, they are giving when soil is in a densest state, that means when the soil is having low wire ratio. When soil is having low wire ratio, again we have to calculate the active earth pressure and passive earth pressure. When the soil is in densest state, when soil is in densest state, wire ratio E equal to 0.36 and angle of interflexion phi equal to 45 degrees. Angle of interflexion phi equal to 45 degrees. For this we have to calculate the, active earth pressure and passive earth pressure for both active conditions in dense state and both active condition in a loose state. We have to calculate. Compare the ratio of active and passive earth pressure in two cases. That means dense state active pressure, loose state active earth pressure. Okay, we'll write the given parameter. Okay, first I am writing the given data. The given data. Okay, again we are having height of the wall. Height of the wall h equal to 5.40 meters. Height of the wall h equal to 5.40 meters. Next common data I am writing, that specific gravity of the soil, specific gravity of the soil G equal to 2.64. Specific gravity of the soil G equal to 2.64. Next I am writing the first condition as loose state. I am considering the loosest state. Okay, first I will calculate the active earth pressure and passive earth pressure for the loose state. Second I will calculate the active earth pressure and passive earth pressure for the dense state. Later we will let the ratio. Okay, for this condition, for a loose state they are giving this wire ratio E as 0.60. Okay, next as well they are given the angle of interflexion phi equal to 27 degrees. Angle of interflexion phi equal to 27 degrees. Now we have to calculate the total active earth pressure and total passive earth pressure. Suppose this is your retaining wall, and this retaining wall height having a height of 5.40 meters. Retaining wall having a height of 5.40 meters. Okay, for this the total active pressure. Okay, I am writing total active earth pressure or total pressure at base of the wall. Okay, total active earth pressure we can write the total active earth pressure. The total active earth pressure. The total active earth pressure. The total active earth pressure is nothing but PA1 equal to half into KA1 into gamma loose into H square. Gamma loose into H square. The total active earth pressure equal to half into KA1 into gamma loose into H square. If you see here, KA1 value we don't know, gamma loose value we don't know. First we should have to calculate the KA1 value and gamma loose value. How KA1 value it will become? KA1 is nothing but coefficient of active earth pressure. The coefficient of active earth pressure KA1 equal to 1 minus sin 5 divided by 1 plus sin 5. That is equal to 1 minus sin 27 degrees. 1 minus sin 27 degrees divided by 1 plus sin 27 degrees. That is the coefficient of earth pressure in losses. Okay, that means 1 minus sin 27 degrees divided by 1 plus sin 27 degrees. Okay, I am getting this KA1 value as 0.375. I am getting this KA1 value as 0.375. Next, I want to calculate this gamma loose value. Here E value I know, phi value I know, specific gravity of the soil also they are given in the problem. The specific gravity of the soil given in the problem as 2.64. Okay, now I am calculating the density of the soil, that means unit weight of the soil in the loose state. That unit weight of the soil in the loose state, gamma D loose equal to G gamma D loose divided by, that means in loose state divided by 1 plus E. If you don't want to confuse, you can write G gamma W by 1, gamma D equal to G gamma D equal to G gamma W. Gamma D equal to G gamma W by 1 plus E. Gamma D equal to G gamma W by 1 plus E. Again I am writing here gamma D equal to G gamma W divided by 1 plus E, where G is the specific gravity of the soil given in the problem as 2.64 and gamma W is the unit weight of the water 9.81, 1 plus E, where E is the wire ratio, that means 1.06, 1 plus 0.6. Total we are having the gamma D loose value. That means the unit weight of the soil in the loose state. That is nothing but 2.64 into 9.81 divided by 1.60. We are having the unit weight of the soil in loose state. It will be 16.18 kilonewton per meter cube. 16.18 kilonewton per meter cube. Next, we will calculate the total active earth pressure. The total active earth pressure equal to PA1 equal to half into KA1 into gamma loose into H square. Okay. The total active earth pressure in loose state PA1 equal to half into KA1 into gamma D loose into H square. Gamma D loose into H square. That half into, where KA we are having 0.375. KA equal to 0.375. Gamma D loose we are having 16.18. Gamma D is equal to 16.18. Where H square is the height of the wall. That height of the wall it will be 5.40 meter square. Next we are having the PA1. That PA1 equal to total active earth pressure in active condition in loose state equal to 0.5 into 0.375 into 16.18 into 5.40 square. Okay, I am getting this PA1 value as 88.88 88.46 kilonewton per meter. 88.46 kilonewton per meter. Next, I am writing the directly passive earth pressure in the loosest state. The passive earth pressure PP1 equal to nothing but half into KP1 into gamma D loose into H square. Gamma D loose into H square. Again half into, again Kp is the coefficient of passive earth pressure. The coefficient of passive earth pressure nothing but 1 plus sin phi by 1 minus sin phi. Okay, directly I am writing here 1 plus sin 27 degrees, I think sin 27 degrees, and that means 1 plus sin 27 degrees divided by 1 minus sin 27 degrees. Half into Kp1 into gamma D loose already we have calculated to be 16.18 into H square nothing but 5.40 square. Next we are having the total passive earth resistance or total passive pressure. That will be, first I am calculating the coefficient earth pressure 1 plus sin 27 divided by 1 minus sin 27. Okay, that Kp value we are having 1 by 2 into Kp value we are getting as 2.66 into 16.18 into 5.40 square. We are having Kp value as, that means the total passive earth resistance as 0.5 into 2.